Good day viewers, you're welcome to my YouTube channel. Today we have the following problem. So we have this triangle, that is the right angle triangle with the inscribed circle, and we are asked to find the area of this circle here. Okay, now we need to get the radius of this circle before we'll be able to find the area according to my own solving. Now we all know that this is a right angle triangle. This is a right angle triangle, and we need to find this angle here. So we need to find this angle, we need to find this angle, and we need to find the other angle here. Okay, now we record that tan of this angle here, tan of this angle here, so let's call that angle theta. Tan of theta is equal to, the opposite over the adjacent, so that is 3 all over 4. Then theta is the inverse tangent of what? 3 all over 4. Inverse tangent of 3 all over 4. So this is this angle here. Now this one here, let's call this angle here beta. So let's call it beta. So we have tan of beta is equal to, opposite over adjacent. So this side now is opposite since the angle is facing this side, and this side is the adjacent. So that is what? 4 all over 3. Then beta is equal to the inverse tangent of 4 all over 3. Okay, now we need to do something like this, something that looks like this. So now we know that this is the center of the circle. So this is the center of the circle here. So I'm going to draw the following line, so that divides this angle into 2 equal parts. So what do I mean? So I have the following line. Okay, now I have the following line here again. So I have this line here. Okay, now I have this point here. So I have another point here. So I have this. Very good. Now we can see that we have 2 right angles here. So we have 2 right angles here. Now remember, each of this angle here is when the value of beta is divided by 2. Okay, now let me denote here. Let me say from this length to this length is x. Therefore this length, that is, remember we have, okay, let me say here is A, here is B, here is C, and here is D. Okay, now we all know that AD is what? 5 minus x, because when you add this length and add this length, you will get this 5 here. So that is 5 minus x plus x remains 5. So now what is the next thing to do? Remember that this is the radius, this is the radius, okay, and this is x, this is 5 minus x. So we are trying to link these triangles with the radius. So now what is the next thing to do? So we know that each of this angle is when this beta is divided by 2. So we have each of the angle when beta is divided by 2, which is 1 over 2, the inverse tangent of 4 all over 3, and this is approximately equal to 26.565. So we say that each angle here is what? 26.565 degrees approximately. So 26.565 degrees approximately. So now the angle theta here, so this angle theta is when the angle theta here is when this theta is divided by 2. So we have it as theta all over 2 equal to 1 over 2 the inverse tangent of 3 all over 4, and this is approximately equal to okay, 18.435 degrees. So now we're going to use this rule of SOHCAHTOA. So we have this angle here as 18.435. okay, now we have this right angle here and we have this right angle here. Okay, now this angle and this angle, they are on a straight line. So we have 90 plus 90, which is giving us the sum of angles on a straight line. So when we have this now, so we're going to link this. So we say that tan of this angle here, so tan of that angle here, tan of what, 26.565 is equal to, is equal to opposite over adjacent. So that is what, radius all over, that is radius all over 5 minus x. Okay, and the triangle here, the right angle here, so we have tan of 18.435 degrees. 435 degrees is equal to, that is opposite over adjacent. So that is what, radius all over x. Okay, now when you use calculator to evaluate this tan of 26.565, so this here, tan of 26.565 is giving us 0. That is 0.499999 and so on. So this is approximately equal to 0.5. So this is approximated. So this will be 1 all over 2. So this is 1 all over 2 equal to what? R all over 5 minus x. Okay, and this one here, that is tan of 18.435 is 1 all over 3. So that is equal to what? R all over x. So we're going to cross multiply. So when we cross multiply here, we have 2 times r, which is 2r, equal to 5 minus x times 1, that is what? 5 minus x. So the second equation, 3 times r, so 3r is equal to x times 1, that is x. So we're going to substitute this value of x here into this equation 1 here. So this is equation 1 and this is equation 2. So when we substitute it, this equation 1 becomes 2r equal to what? 5 minus 3r. So add 3r to both sides, so we have 5r is equal to 5. So therefore r, that is the radius of this circle here, is going to be 5 divided by 5, and that is what? 1 units. So that is what? 1 units. Now since we have gotten the radius, no need for solving for x. So we quickly find the area of the given circle inside here, which is the inscribed circle. So remember, area of a circle is equal to pi r square. So therefore area of the circle is equal to what? Pi times 1 raised to the power 2, which is equal to what? Pi in units. So this is the area of the inscribed circle, which is pi units. Thank you for viewing, and make sure you subscribe to my YouTube channel for more interesting videos.